Hello kids, today we are going to explore build an atom simulation with FET simulations. So let's get right into it. You go to your Google search, write FET simulation. You go to this fet.colorado.edu link. Once you open it, you get to this page. It's actually a simulation tool. So we're going to explore the building an atom. For that we need to go into the chemistry section. Over here it's going to give us all the topics that are available in the form of simulations. So right at the bottom there's the build an atom simulator. Let's click this, let it load. Once it's loaded, you can click on this play button, and I would highly advise the students to please explore this using a computer with a good internet connection, so that you get to have a smooth experience of this simulation. Let's go to the building an atom simulation. There's a game as well where you have to identify the atoms of the given structure, but you have to identify the structure as well, right? But first we're going to build the atom. Okay, here we go. Let's we do know that in the middle there is supposed to be nucleus, right, of an atom, and these are the electron orbits, and they will increase once we start putting in these electrons over here, right? Now we know an atom is made up of three fundamental particles: the protons, the neutrons, which make up the nucleus, which is in the middle. We also call them collectively as nucleons, right? Nucleons is another name for what we call as components which are available inside the nucleus of an atom. That's proton and neutrons, right? Now on the outer side we have these blue particles which we call as electrons. These are negatively charged and they revolve around the nucleus. So let's see. Let's put a proton in the middle, and with one proton and one electron we have this element called hydrogen, which is the first element in the periodic table. Now let's see what happens if we just take this electron away from it, right? And there you go, it's a positive ion, right? And this is what the hydrogen ion should look like in the form of an atomic structure. No electron on the outside, no electrons at all, and one proton in the middle. Now the most abundant form of hydrogen has only one proton, doesn't have a neutron, just one electron, one proton, making it a neutral atom, right? And a neutral atom is one that has a balance of both the positive and the negative, right? If the positive is greater, then the net charge should be positive, making it a positive ion. And if the negative charge, let's put two electrons over here. Now as we know that this over here we have one proton in the nucleus. Now we have two electrons on the outer side, so the negative charge is now greater, so we have a negative ion, right? And with the balance we have a neutral atom, right? Now we can also view this as an electron cloud. This is how the actual atom is supposed to look like, but for the sake of our understanding and ease of study, we're going to stay on the orbit simulation instead of clouds. So let's keep on adding these particles. Let's put a neutron. Now this is another atom of hydrogen, which we call as deuterium. It's an isotope. Now what's an isotope? Isotope is a family of atoms that share the same chemical properties, as they have the same number of electrons on the orbits, while they have different nucleon number, right? That means the number of particles inside the nucleus vary, right? Now this is the second isotope of hydrogen, and if I add another neutron, which is a neutral particle, does not have a charge, so the charge is still neutral as we have a neutral atom, but as you can see we have now three particles in the nucleus. We can view it as a cloud again, right? So this is the third isotope of hydrogen, right, which is known as tritium. Now it has two neutrons, one proton and one electron on the outer side, right? These are the three isotopes of hydrogen. uh, Tritium with a 3, deuterium with 2, and a protium with no neutron in the middle. Still a neutral atom, right? So do explore this. You can make several atoms. Like I'm just gonna throw, a bunch of neutrons over here, and let's see. We need to put in the protons, and now you can see as soon as I'm adding more protons, the atomic number is changing. The periodic table displays here for your ease, so you can check how you're moving through the periodic table, how the atomic number is changing. Since the atomic number is actually the number of protons, so as we keep on adding protons, uh, the atomic number increases. Now we've got to neon, right? It has a total of 10 protons, and as you can see, it's a positive ion, so we need to balance the number of electrons. 2 in the first orbit, right, the duplet rule, and about 8 electrons can be adjusted in the next shell, right? What we call as the octet rule. There we go. We think one more. Yeah. Now it's a neutral atom, right? The number of electrons and protons are now balanced, but as you can see, the number of neutrons are less. So for a stable atom, let's put equal number of neutrons in there as well, right? Now this is a stable atom. Now we'll discuss what's a stable and unstable atom. We can switch to it as well. So it will tell us whether the atom is stable or not. If I remove neutron, then it's unstable, because there is no more balance inside the nucleus, right? The number of protons is greater than the number of neutrons, in which usually the number of neutrons are greater than the number of protons in most of the cases, and we can say that these nuclei will be unstable if they are not balanced, right? So let's put the neutron back in. Now it's stable. As you can see, no more movement, and the number of electrons are also equal to the number of protons. So as a whole, the atom is neutral as well as it is stable. The stability depends on the nucleus, and the charge depends on the presence or the absence of these electrons, right? The absence means positive ion, and let's see, let's reduce the atomic number, right? Oh, it's still not balanced. I think we need to add more neutrons. Yeah. Okay. Here we go. And in case of increase in number of electrons, we have a negative ion. I hope this clarifies how the atomic structure behaves. You can explore, different features of this app. It has the charge. Right now we have the negative charge more, so it's towards the negative. Let's balance it out. So you can check and explore this app. It's a amazing tool. Just leave your queries in the comments if you have any questions. I'll try to respond those. Thank you.